Hello, everyone. Thank you for coming today. We have a lot to cover today. My name is Sarah Bullock, and I'm a marketing associate here at Ekotrope, and I'm joined by David Pedrick, who is a product manager, and Emily Steele, who is strategic accounts manager here at Ekotrope. And they'll be sharing some insights regarding the focus of today's webinar, which is IECC 2021. The agenda for today's session is as follows. We'll do a brief introduction to Ekotrope for anyone who's not familiar with us, and then we'll jump right into an overview of IECC 2021 and some of the new requirements, as well as some of the states and municipalities that are adopting it or plans to adopt it in 2023. Then we'll do an analysis of homes that passed IECC 2021 and 2022 of homes that were rated an Ekotrope-rated, and share some of the key specifications for compliance and performance buffers. Lastly, we'll get into an energy savings analysis for one Midwestern utility that essentially shows how claimable savings for utility new construction programs are impacted by the new code requirements. And we'll finish it off with a little bit of Q&A. And with that, I'll let David take it away.
All right, thanks, Sarah. So today, what we hope to be able to answer for everybody on the call today is to what specifications homes can be built to comply with IECC 2021. So there's lots of different ways that a home can be built and comply with this energy code, and we want to highlight a few different ways that those homes can be built to help share the knowledge of how we will move towards this code throughout the country over time here. Second point we want to be able to answer is what appliances do raters and builders need to pay special attention to when planning their projects? And we expand this out of just appliances to building specifications, to wall components, ceiling components, what have you. And the third question is, what opportunities does IECC 2021 present for building product manufacturers? So this is related to the first one, where we'll use a tool that we have to analyze how a specific building product or specific building specification changes compliance thresholds, so you can see how much benefit something has on an entire portfolio of homes. And finally, like we said, we'll answer how will IECC 2021 impact utility new construction program energy savings for utility rebate programs. This new energy code is a little bit more stringent, a little bit more energy efficient than codes in the past. So that has some impacts to other above code programs. So with that, I'm going to do just a short little introduction to Ekotrope. Here at Ekotrope, we're a software company that develops tools that brings energy performance data to all home building decisions. To do that, we're building products for home energy raters, for builders, for lenders, for utilities, for product manufacturers, and homeowners to put them all on the same platform so they can look at the same data, see the same insights, and share that knowledge and come into one spot to have that information to really make the best decision for their bottom line and for the environment. So the way we do that is first to build an energy modeling software that now is used on about 1 in 4 new homes built in the US every single year, which means we have about 1 million homes in our database that are actively being lived in today and that we can provide insights on to help inform future decisions about housing decisions. We're also the top provider of 45L reports, as well as other rebates and utility programs. So we're able to use all that data to make key insights about how a home can be built to earn more of those credits, meet more of those energy codes, or save the homeowner or the person who lives in the home a little bit on their utility costs for the idea of total cost of ownership for a house. So with that, I want to transition into talking about what is this new code. The IECC 2021, IECC is the International Energy Conservation Code. It's a standard code that's written and released every 3 years, and it gets pushed out into the world, and states will adopt it as is or make small amendments. We're going to be talking about the standard International Energy Conservation Code 2021 edition. It's being adopted in a few states across the country. So I want to give a little bit of detail about what is in this code first. So for those of you that kind of read this code, work in this code, there's 3 compliance pathways. The prescriptive code, which is a list of prescribed or required R values and equipment for various housing types in various climate zones. There's an alternative compliance pathway here for a total UA compliance that allows some trade-offs. They have backstops as well, and that's the prescriptive code. The other compliance pathway for this code is the ERI target. So the ERI target, ERI is an energy rating index, and in the code it says if you meet this ERI, you will pass the energy code. Not everybody adopts this portion of the energy code, but it is in there. It is a compliance pathway. The third compliance pathway is a performance target. The performance target is a target utility cost for that home that your as-built home needs to exceed or perform better. So for example, if it says for the performance target, it says the reference home or the threshold that you have to achieve to pass energy code is $100 per month of utility costs. This is just a made up example. In order for the home to pass, the energy model has to show that the as-built home's utility cost will be less than $100 per month. And that is, then we introduce kind of a concept called margin or performance buffer. That is the difference between the reference home's energy cost and the as-built home's energy cost. So for example, the as-built home, or the reference home uses $100 of utility cost per month, and the as-built home uses $95. That buffer or margin would be 5%, 95 over 100, and the difference there is 5%. So that's how we talk a lot about this code. And we're going to talk mostly about the performance code, actually exclusively about the performance code, because that is how most homes that use Ekotrope show code compliance. It's also probably the most common, more popular way to show code compliance as well across the country in places that use this energy code. So we'll be talking about performance. We'll be talking about the reference home. We'll be talking about performance buffers and margins quite a lot here. And the third thing that I want to talk about is this concept of a reference home. So every single energy model is being compared against a reference home to show what that buffer is, how much better the as-built home will perform. And the reference home is defined in the energy code. It changes based on some characteristics of the as-built home as well. And it's kind of the benchmark that you're always comparing against to show show code compliance. So once we kind of have that concept, we can talk about what are some key specific changes in this energy code. And the biggest changes are, first, the installation R value increases have increased, and sometimes significantly. Number 2, there's an ACH requirement. 3 ACH used to be mandatory in the 2018 code, and now it's being pulled back to 5 ACH 50. Now, we're going to talk a lot about this in future slides. Some people see some concern here that now homes are going to be a little bit more leaky because of this, but we don't think that's going to happen because there's still a lot of incentive to build a high performing home because you get a lot of benefit from that in the energy model. So builders are going to make a cost benefit analysis here. And we think they'll likely still decide to build a home that is 3 ACH or tighter in those places because of the cost benefit that they see. Number 3, there's some new and modified mechanical ventilation fan requirements. This has mostly to do with cold climates requiring HRVs and ERVs, and central fan integrated systems having some fan efficacy requirements that will need to be taken into account. Number 4, roughly 10% of counties in the US have changed to a new climate zone. This is climate change is real. This is the planet is warming counties that were on the border of a climate zone have moved into the warmer climate zone. And, people need to be aware of that. People need to account for that when they're building these new energy models. We've mapped all those new counties to the new climate zone in our software, so we take care of that for you. But there are places where this causes some interesting scenarios, which I'll talk about here in a little bit. Number 5, there's increased lighting efficiency requirements to encourage more LED use, to move from CFLs into LEDs now. Number 6, there is a new section in this energy code. So in the performance code, it now says you have to, your utility cost has to be less than the reference home, but it also needs to include an enhanced energy efficiency measure. Those enhanced energy efficiency measures vary, and they are, let me look at my notes over here. An additional UA compliance threshold. So you have to have a total thermal building envelope performance better than the reference home, improved HVAC systems, better domestic hot water systems, distribution systems inside conditioned spaced or the building envelope. And then the last option that is part of this enhanced energy efficiency measure would be 3 ACH50 with an ERV or HRV. And those are kind of like the 5 options. There is a 6th option there, but those are kind of the primary ones. And as long as, so you have to meet the performance criteria, which is perform better than the reference home, but then you also have to do one of these enhanced energy efficiency measures. Now, the final big change is to throw out what I just said and say that you don't have to, you have to pass the reference home by not just a little bit, but by a whole 5%. So in my example, where if the utility cost is $100, in order to pass, you have to be at $95. You can't be at $99. It has to be a full 5% passed. And so that makes the threshold just that much harder to get to. There is one caveat here, though, that causes some confusing logic. So if your home, as modeled, is at 96% less or 4% less utility cost, it can still pass the energy code if you can remove the one enhanced energy efficiency measure that you used in the energy model. And after you do that, the home still performs better than the reference home. So for example, if you are at a 4% less than the reference home, you take out your higher efficiency HVAC system, and now you're at 99% of the reference home, or 1% reduction, you would still pass the energy code. So there's some logic and criteria there that get evaluated in Ekotrope when we do that analysis, but there is that kind of caveat there. So let's talk about places where this has been adopted. So there's a few states that have adopted this energy code: Montana, Nevada, Colorado, Louisiana, New Jersey, Connecticut, Maine. Colorado has a law in the books to part of their energy efficiency and greenhouse gas emission changes. It is a home rule state, so it's kind of uncertain how that's being rolled out there. There's places like Colorado Springs that is amending the IECC 2021 when they adopt it in that region. And then we have states where there are cities that have adopted this code. That's like Austin, Texas, Kansas City, Missouri, and Chicago, Illinois have all adopted this. And then there's the states that are looking to adopt this in the future. And those are in the dark blue: Minnesota, Michigan, Indiana, Vermont, and our home state, Massachusetts. So one of the changes here is the climate zone change. And so there are places that have moved into warmer climate zones. The one place that this is kind of may cause some problem is in the Dallas-Fort Worth metro area. That metro is very large, and Texas has lots of small counties. The climate zone map is based on counties, so an entire county is in a particular climate zone. And there are subdivisions in the Dallas-Fort Worth area that go across a county line, and also across the climate zone. So the same house built in two different locations in the same subdivision may need to follow different requirements because it crosses the climate zone and across the border there. One of those crazy things that happens when we have to draw lines on maps in real places. So now that we have kind of an understanding of what those changes are, how the code works, we want to talk about how homes that were built in 2022 were built and look specifically at homes that passed at least the performance criteria in this new code to get a sneak peek into kind of how we think homes will need to be built in the future by looking at homes in the past that if we evaluate over the future requirements, already meet those requirements. So to do that first, let's look at broad overview. On this map here, we have the states that are either adopting, have adopted, or have cities that have adopted, highlighted in thick font. And on the left, we have what the median IECC buffer is for each state. So if the median is at 0, that means half of the homes have a buffer of greater than 0 and half less than 0. The buffer is greater than 0, it means it's exceeding, it's performing better than it needs to pass that energy code. And so we have some states like Texas, Colorado, Nevada that look like their median buffer is greater than that. So those states are looking like they're in a spot that will, they're in a spot that they're prepared to adopt this new energy code. Their building practices are up and about to catch up to this code. But then places like Montana and Louisiana that are also adopting this code, their median is very low. So there's a lot of disruption, a lot of change in building practice that will need to happen there to meet this new energy code. Then on the right, we can see a similar thing, but see the portion of homes that do pass in those states. So as we expect, Louisiana actually has a very low number of homes that would pass for this new code. These are all homes built in 2022. And Texas actually has a fairly high percentage of homes that would actually pass this new code if it were to go statewide. Obviously, there's HB 3215 there that is kind of setting Texas on a little different track as people move into these newer code cycles. So now let's look at how these homes are actually built. We're going to look at a few different key characteristics. First, let's define the homes that we're looking at. So if we take all of the homes that are input into Ekotrope in 2022, 45% of those pass this new energy code. And by pass, we say their buffer is 0 or greater. We understand that 0 to 5%, some of those may not actually pass once you remove the enhanced energy efficiency measure, and all of the homes greater than 5%, as long as they have advanced energy efficiency measure, they do pass. There's about 100,000 homes there. We're going to focus on those homes to see how they are built, to see how the rest of the homes, the kind of specifications those rest of the homes will need to follow. Additionally, there are about 5% or about 12% or 30,000 homes that almost pass within that 5% boundary on the negative side. So if we look at the main differences between these two populations, between the homes that don't pass and the homes that pass, what are the key differences in different climate zones for those two, the ones that don't pass and the ones that pass? And the major differences are here. In climate zone 6 and 6A and 5B, the biggest difference was the median ACH number. So the ones that failed had 2.8, the ones that passed had a median of 2. So moving forward, even though the ACH number requirement is rolled back to 5, it seems as though a good spot to end up is in this 2 ACH region, because that gives you a good chance to pass and kind of balances all of your costs. In climate zones 5, we see similar ACH changes, but we also see a small change in cavity R value and a small change in the median ceiling cavity R value. So the space between the roof joists for the ceiling trusses, there's more insulation there in climate zone 5. Finally, in climate zone 4, similar ACH, but then like climate zone 2, there's a big change in continuous insulation rates on above grade walls. So in those colder climates, they're saying we need to add some continuous insulation, and that's the biggest difference between homes that fail and homes that pass IECC 2021. So let's dive a little bit more into this ACH question. So like we've kind of said, a lot of people are concerned that with the rollback to ACH 5, homes will automatically just go back to that. But if we look at just homes that currently fail or pass this new energy code, what ACH value did they choose to meet? Now, if we look at, so we've picked out a couple states, Colorado and New Jersey, places that either are or have adopted the new code. And you'll see there's one obvious pattern. A lot of homes are built to 3 ACH because that's what the requirement is today. But even those homes that pass IECC 2021, the most common values are around that 2 ACH number. So those homes where they could, roll it all the way back to 3, they chose to instead say, no, it's actually, makes sense to go down to 2 because that has some value for us. So we expect that similar thing to happen. Some builders will be like, that's the backstop. We're going to go all the way back to 5. But it looks like most are deciding that, something underneath threshold, underneath the requirement is the best option for them still. So we expect that trend to still be consistent as we move into the new code. Now, we know builders do like to make trade-offs, like I was just saying about, deciding that the 2 ACH gives them the best option to meet energy code. And all of these different things, that's the benefit of the performance code, is you can trade one thing off for another thing to, maximize your energy performance and minimize your cost. So we picked out a few homes in New Jersey, and not just a few homes. What we actually did is we took all of the homes that pass in New Jersey and clustered them into similar clusters of homes. And similar meant that they had similar values of these different variables. And then we asked, what are those actual clusters, to give us an idea of how people are trading things off. And one trade-off that we saw was 13 SEER AC, 96 AFUE furnace with R23 cavity insulation, no continuous, and 2.3 ACH 50, R43 in the floors, R45 in the ceilings. These numbers may look a little goofy because this is the effective, this is the U value of that component, and then we converted it to an R, so 1 over R. So you're not going to be able to go and buy a bat of this exact R value, but that's kind of how what our methodology was there. And water heating efficiency of 0.93 EF. So that's one cluster, one specification that passes this energy code. Another one looks like this, where they did slightly less wall insulation and made up for with a little bit more continuous insulation. And then they had a little bit less floor R value, a little bit less ceiling R value as well. And then another one is kind of a hybrid of both of those. And you can see our little Candyland chart as it goes down around here to the different specifications. So a few takeaways for this, for the new energy code, is that about 45% of homes built and entered into Ekotrope in 2022 also passed the new energy code standards. Different states are meeting this new code at various levels, ranging from 25% to 75%. So some states are really prepared to adopt this energy code. Others are going to need really big changes and a lot of help to get their housing stock or their new housing stock to adopt these new building practices. And those states are Nevada and Louisiana. where there's going to need to be some big changes. Then if we look at it, homes that pass this new energy code will have different trade-offs in different climate zones. So going to across the country, there's not one solution that works everywhere. Each climate zone, each region is going to have something that's a little bit more specific to them, one to their the building practices that they prefer, but also to the climate zone and the building type. And then generally, these differences, like I said, vary across the climate zone, but ACH values tend to be lower in homes that pass this new code than homes that don't. So we expect even when the requirement relaxes, it'll still stay at that lower level. So at this point, I'm going to pass it on to Emily to talk about how utility programs will be impacted by this energy code.
Thanks, David. Hi, everyone. Emily Steele here. I'm the Strategic Accounts Manager here at Ekotrope, where I work with our utility partners overseeing their program implementations on our app. I'll start with a bit of an overview about utility programs as a whole. Utilities run a variety of energy efficiency programs to help builders go beyond code, and they provide incentive dollars to help the builders do so. The utilities run these programs to claim the additional savings generated by building more efficient homes. And builders and homeowners also benefit by either making money through the incentives or by saving money on energy costs. But when a new code comes out, like IECC 2021, the new codes typically raise the bar for efficiency, and it becomes harder for builders to go beyond code. And these utility programs, they then see a decrease in claimable savings. Utilities can update and redesign their programs, though, after a code change to ensure that they are promoting builders to continue to go beyond code. And by adapting the programs, utilities are then adapting to these new baselines for savings. Here at Ekotrope, to help the utility better prepare for a switch to IECC 2021, we ran an analysis on 500 rated homes in Ekotrope from the same state. We first compared these rated homes to the state's current baseline to determine savings by subtracting the rated homes consumption from the reference homes consumption. And then we did the same thing a second time, but we compared the rated homes to IECC 2021 with federal minimum equipment. And then looking at the savings values, or this difference between the rated home and reference homes energy consumption, we noticed that there were significantly lower savings when we compared the current projects to the new IECC 2021 code. And so it's important to remember here that the rated homes were still the same level of efficiency, but since more is expected of them with the new baseline, the utilities' claimable savings decreased. And since IECC 2021 is a more efficient standard, homes that were going beyond state code are no longer going beyond and are no longer that much better than IECC 2021, reducing that delta in consumption. So we have here a chart to dive a bit deeper. We can look at the average therm savings and kWh savings from these 500 projects. And this chart here shows us that if we compare the projects to the current state code, the utility can claim on average about 600 therms and 2,300 kWh per project. But when we compare IECC 2021, when that's required, and we compare the same set of projects to that new baseline, we see a dramatic reduction in savings. The average project actually consumes more gas than the reference home and only saves 533 kWh instead of 2,300. So we see a big drop here. And so again, it's important to remember that we're looking at the same set of projects, so their efficiency level is staying the same, but since more is expected of them, the energy savings that can be attributed to the utilities program, those incentives or those savings have decreased. So overall, a few takeaways. In summary, we saw a decrease in both gas and electric savings when the projects were compared to the IECC 2021 baseline, but we see this as an opportunity for utilities to design innovative programs and to test out new incentives. We believe builders can help push for more efficient designs and for various products to support these efforts to help close out this gap in savings. So with that, I'm happy to pass it back to you, David, to talk about some of our scenario modeling work.
Thanks, Emily. With that, we want to transition to looking at how specific building products and specific building practices impact the IECC energy code compliance. So what we were able to do is we're able to look at a whole bunch of energy models. I think in this analysis, we looked at 600 to 1,000 energy models that were randomly selected out of our database, and then picked a series of different components like a wall insulation value or a HVAC component or a window change. And we're able to make a change, just that change isolated to everything else in that energy model, and understand how much that specific thing impacts the code compliance. And by impact, we're saying how much does it move it towards or past the energy code threshold. So like I was saying before, if our threshold is $100 of utility costs per month, and this home is currently at $95 per month, and we add in a new component, like we switch out all the walls from one R value to another R value, and the new utility cost is $90 per month, we would say that moved the buffer by 5 percentage points, because it went from 5% to now to 10%. And so that's what we're going to do here. So we're going to talk about a few different types of homes, or a few different types of products and specifications, and talk about how that impacts these energy code compliance. So the first one is infiltration. We're looking at two different regions. We're looking at a warm climate and a cold climate. And in this top case, in this warm climate over here, we see that moving to 4 ACH, the first one, 3 ACH, the second, and 2 ACH, the third, have different impacts on performance here. Now, one important thing to remember when looking at this chart here is that we are comparing this change against what that home's current infiltration value is. So if we see that there's not much of a change at 4 ACH, that most likely means the average ACH number for all of these, for the homes in this analysis, were likely right around that 4 ACH value, because when we changed it, it had a very small impact. If it was much worse, we'd expect it to be very negative. If it was much better, we'd expect it to be very positive. And if there's no change, that means that's about where the average value is. So for these homes, we see that the average value is probably about 4. And if we moved it to 3 ACH 50, we see about a 2.5% increase in performance, and 2 ACH, about a 4% increase in performance. Now in this colder climate, the average looks to be closer to around 3, a little bit higher than 3. And so moving that market all the way to 2 ACH 50 will have on average a 4% improvement in performance for all of these homes in this climate zone in our analysis. So if we look at slab insulation, in this case, we can see that we did 3 scenarios, one with an uninsulated slab, one with R5, one with R10. In this case, in the warmer or the cooler climate zone, all of the homes that we analyzed actually likely had better slab insulation than R10 perimeter. So they likely had R10 on the perimeter, as well as some under slab insulation. In the warmer climates, we see that on average, they probably had uninsulated, and an R5 addition in these warmer climates has about a 2.5% improvement, and an R10 has about a 3% improvement on energy code compliance. Then, if we look at walls, we ran 3 scenarios, one in R13 cavity insulation, one R13 with R5 continuous, and the third a 2x6 wall that's R19 in the cavity and R5 continuous insulation. So in both cases, we see that on average, the average insulation is somewhere in between an R13 in the cavity and with R5 on the continuous. And so it's somewhere around there, probably an R15 cavity wall maybe. And we see Adding R5 to that, we get about a 5% increase. Going up to R19 plus 5, about 6% in the cold climate and just under 5% in the warm climate. So that's kind of a ballpark of where you can say this change will improve your performance for an average home in these climate zones. Then finally, if we look at roof insulation, we have R60, R49, R38 changes here. And we see that in this in the warmer climate, the R60 is about a 3% improvement, and in the cooler climate, about a 2% improvement. So we did do some changes for HVAC systems and water heaters. And the important thing to take away here is that it does improve it. The reason it improves the performance is somewhat nuanced and based on the heat loss of the tank of the water heater or the distribution losses of the heating systems, because by definition, the reference home that we're comparing to has the same mechanical system as the as-built home. So we're not going to see much changes there. However, so that means in energy code compliance and the performance path, those HVAC systems matter a little bit less than they do in places like the 45L tax credit, utility rebate programs. So while you may not see a lot of benefit there in energy code, there's a lot of incentive dollars for improvements to those systems from those other sources. A lot of reason to do those for comfort and quiet and efficiency, utility cost reasons as well. So recap of kind of what we saw here in the warmer climates and the cooler climates, 2ACH saw 4 and 4.5% improvement in compliance buffer. And we saw a big change in the 2x6 R19 with continuous installation of R5 as really big improvements as well. So a few key takeaways here. How do homes need to be built in order to comply with IECC 2021? There's no single checklist, and that's the beauty of the performance code, where it gives you lots of trade-offs. But hopefully you learned a few different pathways that we found that homes currently pass this energy code. When you're building those pathways, ACH is really important. Continuous insulation and wall and ceiling cavity, R values are also very important. Improving all of those will be key in those areas that have low code compliance thresholds right now, like Louisiana and Nevada. So big changes and big opportunities for insulation, air sealing, product manufacturers in those locations to change what those builders are currently doing to a new solution. And then finally, with utility programs, utilities will likely see smaller claimed savings for their programs in areas that have adopted this new energy code. Claim savings is how much energy savings that the utility can claim for their program. And they can claim a little bit less because some of that reason for the savings now goes to the energy code. And so utility program is an above code program. And so unless they raise their ceiling as the floor increase, their claim savings, the height of the ceiling is a little bit lower. Still means there's an opportunity there. They just need to raise the ceiling a little bit for those utility programs. So with that, we'll transition to question and answer. Thank you for attending, and I appreciate everybody for staying with us for this webinar. If you have any questions, you can reach out to me at david@ekotrope.com or Emily at emily@ekotrope.com. And as always, info@Ekotrope is a great source of help and support for any of the information here or any questions in general.
Thank you, David, and thank you, Emily, for those insights on IECC 2021. I hope everyone learned a lot today. And as David mentioned, if you have any questions, please reach out to us at info@Ekotrope.com, and we'll see you soon. Bye-bye.